rational equations and functions, some of the key points that I want you to focus on before starting this lesson is that you need to understand that when we talk about rational equations, expect to have an equal signs with rational expressions on each side. You have seen what a rational expression is, so it's not a surprise that we are getting to this point. A second part to this is, even after you solve it, remember, every time we have an equation, expect to have some variable equal to some value. Now, not every solution is considered to be a solution until you completely verify and check to make sure it actually works after you plug it back into your equation. And sometimes, your solution might be called what we call an extraneous, because when we plug it back into our equation, it doesn't work. And so, understand that you need to always recheck your work by plugging in your solution into your equation to check. And it is also possible that you might not have any solutions at all. It is very normal, and I'll probably going to show you what it looks like in a minute. And most importantly, don't forget, if it's factorable, don't forget to factor, whether it's going to be taking out the GCF or actually breaking it down using the Xbox. Okay. And most importantly, what we just learned a couple of lessons ago, or just the past lessons, is that don't forget to find what we call here the universal key. I think I missed the R. Universal key, which is what I call the LCD, least common denominator. Okay, we learned that you cannot combine fractions that are not the same denominator, so we have to find the least common denominators. That applies to rational expressions as well. Okay, so let's take a look at our first example here. Pretend I have something like this. I have 7 over y minus 3 equals to, there's what the equal is all about. This is a rational expression. On the other side, we also have irrational expressions, and because of the equal sign, we now have irrational equations. The trick to this one is just like before. We can certainly look at this as each individual group. This is a group of y minus 3. They stick together. Don't even consider looking at them individually. They are together. And so what we want to do now is we look at the denominators. They are not the same as a group. They are not the same. So what we want to do is go ahead and find the LCD. Now, the easiest way to look for the LCD is think about finding the universal key. That means what? It must match up to whatever I have up here. For instance, this is what I want you to do. Set it up as a structure. I know I have to find a new LCD here, and the LCDs over here too. I'm looking at this and say, okay, well, what do I need to cover y minus 3? Well, to unlock y minus 3, I need to have y minus 3. Absolutely. Okay, so I unlock this part, but as I look over here, remember we want to find a universal key, LCD. To unlock this one, I need a y plus 1 as well. So therefore, I can combine them both together as a universal key, which can unlock both of my denominators. So as you can see, we call this our new LCD, and because we have found it, we also use it on this side as well, because notice that you can use this to unlock that one. Okay. Now, the next step is just to compare what's missing. In this case, I have y minus 3, but the only part that's missing is the y plus 1. And as we learned in the past, whatever it is that you multiply in the bottom to make them the same, you also multiply that to the top. So in this case, to make this look like that, you have to multiply by y plus 1. Therefore, you also apply that to the top as well, as you can see. So whatever's that, when you compare, that is missing, that is something that you're going to go on the top as well. So once again over here, if you compare, I have y plus 1, I have y plus 1, what's missing is y minus 3, and this is the expression that will go on the top. So what you have is y minus 3. Okay. And once we establish that, once we have everything filled in, and of course the LCD is already established, we can certainly cross the entire bottom out, and all we have to do is just solve the top normally. So it's just going to become 7, distributive property, 7 times y, plus 7 equals to 3 times y, and 3 times negative 3, so that's become 3y minus 9. And at this point, we just want to combine my terms, move all the y to one side. So that's become 4y plus 7 equals to negative 9, minus 7 over both sides. You have 4y equals to negative 16 divided by 4, and y is negative 4. Now, don't forget to check your work. It's important because this could be an extraneous solutions, right? So let's plug it back in. 7. This is -4 minus 3. This is 3, and this is -4 plus 1. So this is 7 over -7. This is 3 over -3. They're both equals to -1 both sides. So check, and there you have it. This is our solution for this particular problem. Okay. Now there is another method to solve this. You know, I'm going to explain more about that in class, but for now, just stick to finding the universal key, which is the LCD. Okay. So what I want you to do is go ahead and try number 10 on page 630. Okay. So let's take a look at the next one here, and really explore what extraneous really means. So let's try this particular problem. I have n squared minus 3n. Looks pretty complicated, and down here I have n squared minus n. This one going to be minus 10 over n squared minus, I'm sorry, it's not n, it's 4. N squared minus 4. Okay. Okay, so, you know, just a habit that I always do is that, you know, if it's factorable, I try to factor the best I can. Sometimes it sounds like, yeah, you don't need to sometimes, but, you know, it's best to do it anyway, especially the bottom, because we do want to find if we can kind of break it down in this case. So we have n squared minus 3n. If you notice n squared minus 4 here, recognize that to be a dots because it's a perfect square, that's a perfect square, and there is a difference between them. It's a difference of 2 squares, right? Dots. So we can certainly break that down to just n plus 2, n minus 2. And over here, it's the same thing, so I'm just going to go ahead and write n plus 2, n minus 2. And over here, since I want to make sure it's you know, a rational expression, I turn it into a fraction and just put a 1 underneath it. The next step is for us to find what we call the universal key, right? Because it should be able to unlock everything. So I'm just going to go ahead and set up the format as you can see here. And let's try to find it. I know that my universal key, or the LCD here, should be able to unlock that one. So I will have that same expression included in every single rational. There we go. And then over here, I also need to unlock that n minus 2. And of course, 1 is already given. Everything has a 1 in it, so you know we don't need to have that. So that can certainly unlock that. It's the same, and it's automatically a 1 is already here, so I don't need to care about it. So all you need to do now is just compare. Is there anything missing here? Nothing. So the top will remain the same. Over here, since nothing is missing, the 10 will also remain the same. Here, everything is missing, n plus 2 and n minus 2. So therefore, these two particular expression will also be moved to the top. So there you have it. And once we have everything filled in, we can cross out the bottom, and then the top will just going to be n squared minus 3n minus 10 equals 2. In this case, well, I know what n plus 2 times n minus 2 is. It's just going to be n squared minus 4. So in this case, I guess I don't need to really factor, but this is what it looks like. And I, of course, will try to distribute. Remember, we want to combine like terms. Anything that you see alike, make sure you combine them. And I move the negative 2n squared over. That's going to become negative n squared minus 3n minus 10 equals to negative 8. I also want to move the negative 8 over as well. Remember, reasons because we want to solve for it. And the one way to solve for it is to move everything over to one side and leave the 0 on the other side. And so that we can use the zero product property. Okay, so you end up with this. Now, another step is I hate having negative in front. You know, I can certainly move that away by multiplying everything by negative 1. So that's going to become n squared plus 3n plus 2 equals to 0. And I'm looking at this right here. I can certainly use the x, or the diamond method in this case. It's going to be 2 times 1 is 2. Here's the 3 in the bottom. And the 2 factors is going to give you a product 2, and a sum of 3 is going to be 2 and 1. Okay, so it's going to be n plus 2, n plus 1 equals 0. Notice the reason I can do this is because this is a positive 1. I can use a shortcut. Now, for the 0 product property, I can just go ahead and start setting it up. Here's n plus 2 equals 0, and I have n plus 1 equals 0. I solve for each case. Here's one solution. Here's the other solution. So once again, my advice, always, of course, it's your responsibility anyways to plug these 2 solutions back in to test for extraneous solution, because not everything will work. So what you should do right now is to go ahead and try to plug that back in. Here's my original equation. So I'm going to go ahead and try to plug in -1. Okay, so if I plug in -1 here, that's going to become -1 squared, -3 times -1, -1 squared minus 4. This is 10, I'm sorry, minus 10, -1 squared minus 4 equals to 2. So solve it. This is 1. This is a negative times a negative, so that's positive, so that's 4 on top. This becomes 1 minus 4, which is -3. This becomes -10 over -3, and as you can see, 4 minus 10 is -6. We do have the same denominator, as you can see. And indeed, you do have 2 equals to 2. Now, that is a solution. Let's try -2 to see if it works. Well, I don't have to do a lot of work for that one to see that it will not work, because just by plugging to the first rational expressions right here, I can kind of see that if I plug in a -2 squared minus 4 will end up with a 0, and we know that we cannot have a 0 in the bottom. It will make it undefined. So right away, I can say that -2 is my extraneous solution. Okay, there it is. That's how it works. So just be careful. I mean, you really want to have to test it out before you conclude that, hey, this is my solution. Okay, let's try another one here, quick one, just to show you what happens when you have a case with no solutions. Pretend I have something like this. I'm going to go through it quickly. You have 3x over x minus 4, remember as a group, minus 4x plus 4 as a group, of course. It's a good habit to include extra parentheses, equals to -1, and of course I would definitely use x minus 4 as my common denominator. So I'm just going to use a set of the structures. So it's going to be x minus 4, x minus 4, x minus 4. So since this is already the same, 3x will remain as is, and this is also the same. I also have 4x plus 4 up here. Don't forget, they're both inside of parentheses. This one, since everything is missing, then I will have to move the x minus 4 out. Okay, now I can cross out the bottom. Then the top is going to be 3x minus, don't forget the negative, we distribute to both terms, so it's going to become negative 4x minus 4 equals to -x plus 4. Subtract this, it's going to be -x minus 4. This is -x plus 4. I add the x over, and as you can see, you have -4 left, and there's positive 4 on the right hand side. All the variables are gone. Left hand side does not equal the right hand side. We have seen something like this before, and when this happens, we'll just say no solution for this one. Okay, very simple. So with that, I'd like you to go ahead and try number 20 on page 630 as well. And to wrap this up, I have one last example to show you. It's actually very straightforward. I know it says rational function, but it's nothing other than using the function notation to write it. So here we go. This is about rational function. And remember, when we have function, we usually use this notation. Either it's f of x or g of x or whatever letter you want, but this is the function notation, and it's usually written in this format. Okay, something like that. And if they ask you to solve for it, really, that's all that they really want you to do is to solve for the roots. You have learned about roots before, and to solve for the roots, all you have to do is just set one side equal to 0. So in this case, we want to solve for 0. So basically replace the f of x with 0, and over here, you really want to try to factor each polynomial, both top and bottom. Okay, so let's try to quickly do this. If you do the x on top, it's going to be 8 and 6, and on the bottom it's going to be negative 2 and 1. See, you know how I got these from. This is negative 2 times 1 to get negative 2. The 1 is here. Top is 8 times 1 is 8, and the 6 is the middle term. Don't forget that the terms have to be in descending order. So here, to make the product of 8 and sum of 6, it's going to be, what is that going to get you here? It's going to be 4 and 2. And over here, to make the product of negative 2 and add up to 1, it's just going to be 2 and negative 1. Okay, and I can use shortcut for this case because there is only a positive 1 in front of the x squared terms. So in that case, I can just go ahead and write x plus 4, x plus 2. Down here is x plus 2, x minus 1. And before I do anything extra, I notice that I can actually cancel this one out. And I just end up with x plus 4 equals to x minus 1. And to really make it simple, remember, we want to solve for this, right? So, you know, the technique that I want you to have here is rather simple. You can certainly cross multiply. See, that 0 over 1 is still 0, so, but I just want to teach you that technique. So you just cross multiply in this point, and it's going to become 0 times anything is still 0, and then 1 times that is still x plus 4, and it's become very simple. You can just solve for it, and it's become x equal to negative 4. Please don't forget that you need to go back in and check your work. So I'm going to leave that to you. It actually works for this one, so don't forget to plug it in negative 4 and see if it's indeed going to give you 0 back. And don't forget to try number 24 on page 630. Okay, and we'll discuss this in class.